Welcome back, all Dads from Arduino Techniques. So sorry for a little bit of hiatus with some of my videos due to some leave over Christmas and the like, so we're back into it now. So this video I'm going to look at using TrainController and some Arduino componentry to switch on my power districts using my dumb boosters by Thames Valley. I'll step you through the Arduino sketch by Rudy DeBoer. I'll link all these things below on how I set up TrainController for it, and the connections I use, or how I connect the Arduino and the DCC interface up. Big shout out to all my Patreons out there. Thank you very much for them for supporting the channel. Every little bit counts. Link below if you wish to help me out also. So without further ado, let's get started. MRT Scale Prints, helping you to add realism to your model railway. We are producing craftsman quality prints in various scales, including HO, O and N scales. We are proudly Australian owned and operated. www.modelrailroadtechniques.com. I'm going to go through intimately on how this actually works. Obviously I'm still very new to the Arduino side of things, but this is a sketch that was put together by Rudy, so I will put the link to that below. So first of all, there's a few parameters you need to change. So first of all, you need to define how many accessories that you wish to control by this Arduino Nano, which is what I'm using. So just for experimentation, I've put 11. You could put 1, 5, 7, it doesn't really matter. But what that does mean, you need to then configure the accessory down here. So you can see here on this line 36, address of 1. So that's DCC address 1, 2, 3, and then obviously what the output pin that is connected to on the Arduino. The only other thing I did change around, because I'm using relays, and my understanding is they're a low output, so as soon as you power them up, they effectively turn themselves on. Now I didn't want to do that because that effectively, every time I power up the power to the Arduino, it'll switch the relay on. So I want to be the one that switches the relay on. So what I needed to do is this line 65 digital write accessory output pin, sets it to high. So what that actually does is, so when it powers up, it does not switch to low, it starts high, so it's up to me or the individual to switch the relay on. And then I had to toggle these in reverse. So that's all I needed to do. So compile and upload, plenty of other videos on how to do that, so I won't bore you with that. So let's quickly go over to TrainController and I'll show you what I did there. We'll quickly have a look at the TrainController side of things. So I will just breeze over this. So not really going into in-depth why I've done things, because as I was explaining, this is still very much in its development phase. So we'll go across to my Arduino automation tab. So you'll see all my power districts that I'll eventually have. So the only two that I have up and running properly with this system so far is LBS power or district power, and also UBS. So we'll start with this little flagman here. So the reason I've got a little flagman here is, so when this triggers, this is triggered by this on-off button here, which then triggers in its operation on tab, triggers a button that is over here. So I'll just quickly go back and I'll show you what will happen. I'll go out of edit mode. If I turn on UBS, or no, we'll go LBS because that'll show you the whole system. So it switches, so that flagman switches that on and switches that on, and I'll get to those little buttons in a sec. So I'll go to Beltoma and you can see it's now switched it on. So what we'll do, we'll quickly, I'll just float that tab for a sec. So just keep your eye on up there. So when I turn that off, so the reason I've done that is so it's just a bit of a ready reckoner, so I can go through as the trains track around, I can just make sure that all the districts are on. So I've also gone one step further With it also, I can switch all my power districts on with one button and then obviously have them all off. So the reason I'm doing this is sometimes when I'm doing some profiling or something like that, I might just use the BY, which is where my profiling track is, which is the main yard, and I just want that power to be on. I don't want the whole layout to be on at this point in time. So we'll talk about the little on and off button. So that is purely just what I've made is a 2-aspect signal. So the on and off button effectively is a 2-aspect signal. The reason I've done that is it just adds a little bit more functionality regarding a trigger, just in case I want to do other things later on with it. Also, I already had the icon on and off already made up quite nicely for that by a gentleman who's helping me with this file. So we'll keep moving our way across. So eventually what I want to be able to do is have the power on, and then these buttons here represent feedback from the PSX circuit breakers. So the PSX circuit breaker on my fascia right now is, so when I've got DCC power on, it lights a physical LED, so it tells me what that is doing. So what I can actually do is I can actually simulate, so I can have the power on, which then tells the fascia LED to also be on. So I will have both. So then I've got a few other buttons here. So this button here is the simulating of the short circuit that's coming in. So that'll be connected up to the PSX also. So that also has a red LED physically on my fascia right now. I want to feed that back into TrainController to say when I've got a short. So this is what this means, a little short. And then the way I've set up my PSX circuit breakers by DC Specialties is there's a button, physical button on the fascia that clears the short off. So I want to be able to do this all via TrainController. So I can just literally push that button so you can sort of see the short circuit clearing button, and that resets the track power. So I'll just quickly go into this little 3-aspect signal here that sort of gives us a little more information on TrainController. So the reason why 3-aspect is so I can actually control. So that aspect is DCC power is not on. Green is all good to go. So that turns that on when this little guy here is on, and when we get a short, which is red, that will be eventually probably be maybe a contact indicator, which will be feeding information back into TrainController. So that'll get changed. So as I showed before, this button here indicates the short circuit that's feeding back in and shows that the system's been shorted out. So I'm still trying to work out the best way forward with this. It's still very much in the research and development phase. So some of these buttons might not even have them, might not worry about this little short circuit one. I just think it looks nice because it's just a real ready reckoner looking just at the switchboard saying, okay, we've got a short circuit purely. But what I'll probably more likely to do with that button here will be out and about on the given switchboard. So I'll go to this one. So that'll probably be, so it'll be next to the power buttons here. So when an operator is, say, working the yard and all of a sudden they lose power, they can just quickly look up onto the switchboard, and if there's the little lightning bolt, it means they've got a short circuit. So then there will be a short circuit clearing button on the actual switchboard. So I'm sort of hoping that makes a little bit of sense. As I said, it's very much in the research and development phase. At this point in time, all I've achieved is being able to turn the track power on and off via a DCC decoder, Arduino DCC decoder. And that sort of serves its purpose at this point in time. But the next step is feeding information back into the status of the DCC, and also whether we've got a short circuit and being able to clear that short circuit all via TrainController is what my plan is. So the first thing we're going to look at is I'm going to show you what hardware I'm looking at doing. So I'll start from the top left of this photo, work my way across the top, and then go across the bottom from left to right. So top left and all those components across the top there are all buck converters. So if you're not sure what a buck converter is, it's a DCC voltage coming in, and you can play with the voltage going down, so stepping it down, coming out the other side at the right hand side. So that first one on the left hand side, that's at 12 volts. I know that photo's a little bit hard to see it, but that is purely for all the lighting and other sort of accessories in my hidden staging yard. The next buck converter across in the middle there is at 5 volts, so that's everything to do with the for the Arduino side of things. And the one on the right hand side, that is my track voltage. So I'm using Thames Valley dumb boosters, which allows me to input via a laptop DC power supply different voltages. So what I've been able to do, so if I want to marry up 16 volts at my track, I use a 16 volt transformer. So that's how I do it. I think these are 19 volts. I've just stepped it down a few volts. The little long thin componentry in the middle there, that is the DCC interface. I did a video on that a number of months ago now, so I will put that link below, so I won't lament too much of that. So in short, what it does is from the right hand side here, you'll see the little blue terminals. That's the DCC bus power coming in, goes through the componentry, and then what it does, it lowers it down to a usable 5 volts out the other end, so we can then plug that into the Arduino. So the next logical component is with the green terminals top and bottom, where the arrow is now showing, is the Arduino Nano that holds the sketch for the DCC decoder. Moving across, we're now looking at a 4-channel relay board. So what the beauty of these relay boards are, they can actually be controlled by the Arduino. So that's what I've done there. I've only used 2 channels at this point in time. I will use the other 2 in later projects that are coming up. So they're also Optio protected. So what that means is they've got a separate power supply that just purely runs the coil side of things. And it keeps, if there's any issues with back voltage going through, I'm not going to end up blowing up my Arduino. So here's a very quick schematic of the connections that I've made here. So we'll start up here on the top right hand corner. So this is the DCC signal comes into the DCC interface. So there's 3 connections on the back end of this. So there's a positive that goes to the Arduino positive bus. There's a ground or a negative that goes to there, and the big pin is what they call the interrupt pin, which is on digital pin number 2. So that's the digital signal that comes into the Arduino at 5 volts. So with that, we've got the Arduino Nano here as well. So the only other connections we need to worry about, we've got down the bottom right hand corner, we've got a 5 volt DCC that has come from the Arduino buck converter that we spoke about before. So that goes to the VIN pin and also the ground. So that feeds the power into the Arduino. So the Arduino Nano also has a USB option. So if you do decide to power it that way, you don't need to worry about this 5 volt connection. But being out in the layout, I don't run the power with DCC. Sorry, I don't run it with DC from the USB. So all your different pins that you set up in Rudy's DCC stationary decoder are all listed here. So you remember that I had DCC address number 1 and 2 on pins 13 and 12. So this is them here. So 13 will then go to the VI or the VI in pin of the relay, and then the other second DCC address number 2 will go to VIN pin number 2. So we briefly spoke about these what I call Arduino relays. Now they are totally Optio isolated. So what that means is there's an Optio coupler here that when the 5 volt signal turns on a little LED inside the coupler, it completes the circuit and it allows the relay coils to activate effectively. So the beauty of these are you can split the power supply off, and I do suggest to do this. We touched on this briefly. So these relays can be used for some quite high current type applications. So some people are actually using them for their mains power. I personally know that I don't have the electrical knowledge, so unless you do, please don't try it. So what that allows, if there's an issue with the say the power at the sharp end here, it can't be fed back into the microprocessor and basically blow it up. So all right, so the bottom right hand corner of that, zooming in, you can sort of see a little jumper. So this normally, so for this to work the way you would take that off, but obviously the photo I had online did not have that jumper removed. So what that allows you to do is you can feed a separate voltage to power the relay coils. So that was the other one, the 12 volt DCC via the buck converters. So that you got a positive and negative. You got a negative that goes to the ground, which is here, and then you've got a positive that goes to the JD VCC. And the very important one here, then you actually need to splice off the actual Arduino power, and that goes to just the VCC. So on the back end here this is sort of how, when I explain to you how it all works. Now, you've got the DCC power supply that comes via the buck converter, the 16 volt buck converter. So that is the desktop power supply, or the laptop power supply I should say, that powers the power district booster. So the way my dumb boosters work, the power district requires a 16 volt or A voltage, what you want at your track level, to power up the componentry. Without that, you do not get any DCC current or communication out the other side. So that's how I've powered it. So you have that coming into the common. So this is actually wrong. So this goes into the common, and then I've then got in the normally open pin, which is this bottom one here. So these need to be swapped around, so I do apologize for that. So the normally open pin, so when this activates via the DCC address, the relay closes and then completes the circuit, and then it powers up the booster. So you're probably asking the question, why do I want to do this? So the main reason I want to do this is often when I'm working on parts of my layout, I want some track power on any given area, but I don't want to have the whole layout turned on. So I run a program called TrainController, which is German software, and I wanted to be able to turn the track power off via TrainController on the computer using DCC equipped on and off switch to be able to turn any given booster or power district off that I wanted to. So I'll show you what I'm trying to achieve here. So the track currently you're looking at is one of the tracks for the upper Beltama staging area. So behind that is a Samsung tablet that's running Smart Hand, which is an application that allows me to remotely control anything on my train controller. So currently I've got the Arduino automation switchboard up. So here I've only currently got 2 power districts up and running where I can actually switch them on and off, but these are all my power districts across the Fallen Log Railway. So the ones we're gonna look at using is LBS and UBS. So this is this area that we're talking about here. So currently we'll switch on the UBS, which is going to then fire up this little locomotive here, which is a 9810. I'll just quickly, I'll have its horn on, or sorry, its bell on. So you can see that the little on switch has come on. So then it's just a matter of turning it off. So that obviously then turns the track power off proper. So quickly what I'll do, I'll just turn LBS on, which is the lower part of the staging yard. And the same drill, I'll have a locomotive, which is a steamer, which is a BR19, another little German favourite of mine, or big German I should say. So I'll just quickly go and turn that on. You can hear the horn going off on that quite loudly, so we'll turn that off. So my ultimate goal is, and I'm hoping I'll be able to achieve it, but you can see we've got a few other little icons here. So this button on the far right hand side is what I'm currently using to indicate what a short's going to look like effectively. Just want a concept to see what the concept's all about. So the icon here on the far left hand side is the indicator to say there's a short circuit. That's what these two lights are. Some of them I might get rid of. I might get rid of this this signal here. So this little this red little sunshine type thing is what's going to be the button that will clear the shorts. So if you see what happens, I'll just go and push on that button and it clears the short and turns the track power back on properly. Little way off with that side of things is I'm still trying to work out with Arkamora and in contact with Nico from there to try to work out how I'm going to achieve that and whether I can actually achieve it with the hardware that I'm currently using. So thanks for watching. So if there's any questions you got below about what I'm doing or any ideas about how I might be able to move forward with this, particularly the Arduino side of things, I'm very new to it, so please comment below. So it's just something I've been looking at doing for a very long time, and now I've sort of fallen down the Arduino rabbit hole. I'm really looking forward to sort of working out how I'm going to do this and with the cheap componentry, and I'll put all the links below to everything that I'm using here, from the Arduino and the DCC interface and the relays and the like. So anyway, thanks for watching, and I definitely will be doing some more videos in the future on this side of things. So we'll catch you later and we'll see you next time. Make sure you subscribe, click that little bell icon to be notified of upcoming videos. Support us on Patreon, like us on Facebook and Instagram at Model Railroad Technique.